All right, hello, welcome to yet another episode where we shall be looking at the preparation for the grade 8 mathematics paper 1 for 2024. Okay, so in this paper, we have round about 10 topics that we shall be looking at, but at least we shall have a bit, okay, not too much of every topic, just once every topic is covered, bit by bit of the questions will be explained. Okay, so this particular paper has 5 questions, and out of the 5, these are the instructions whereby the paper consists of 5 composite questions. Section A has the multiple choice. Okay, so with multiple choice, we only have to circle the correct option. Okay, if the option is A, then we circle A. If the option is B, then we go with B. Then the other questions must be answered within the spaces. Programmable calculator, which is non-programmable, must be used. Graphs calculations, they have to be shown. Then answers only will not guarantee you the full marks. In other words, we have to show how we obtain the answers, okay? Numbering system must be maintained as that of the paper, but in this case, we're not going to need it. And then we have to write legibly and neatly. All right. So with question 1, or the first section rather, they are telling us to calculate the following, okay? So in such cases, we need to look at term by term or number by number so that we can get our final answer. So if we look at the cube root of negative 64 plus the square root of 36, so we know that the cube root of negative 64 is going to be negative 4. And then we are adding the square root. Square root is a number that multiplies by itself to give us that particular number, which is going to be a 6. So if we have a date of 4 and then we have 6 runs, pair the date, we're going to be left with just 2. So our correct option will be C. And then 1.2, you are in Spain and then you want to buy a souvenir. The price is 35 euros. And the exchange rate is that 1 euro. Now 1 rand is equivalent to 1.15 euros. How much rands do you need to buy the souvenir? So this is an example of proportions. Let's see. If we have the euros, let's put it on the side of the euros, which is 30. We're looking for the rands. For us to get the answer, let's get the side that has both values known, which is 30. You divide it by the first number, which is 1.15, multiplied by 1, which is on this other side. When that is done, our answer becomes 30.43. So the correct option is a B. Then 1.3, which is the exponents. Since we are multiplying numbers with the same exponent or terms with the same bases, we shall have to do the addition of the exponents. So that's going to be 3 plus 2 plus 0. And then we shall end up with x to the 5, which is option D. Remember, multiplying numbers with the same bases, terms with the same bases, we add up the exponents. 1.4, they want us to solve the following. So in solving, we always have to make the unknown to be on one side and then move all the other numbers to the other side. So in this case, I'll have my 2x on the left is equivalent to 11. Let's move the 7 that side, minus 7. So when numbers cross the equal signs, the signs must change. So 2x is equivalent to 4. Divide both sides by 2, which means x is a 2. Correct option is B. Then 1.5, choose the correct equation below that defines the relationship between the input, which is the x, and then the output, which is the y. So I'm just going to use the options we have and see which one is going to give me the corresponding values. Okay, let me look at option A. So if I have 3 times negative 2, it's going to give me negative 6. When I subtract 1, I get negative 7, which satisfies that. Then if I have 3 times 4, that's a 12 minus 1 gives me 11, which is that. 3 times 10 is 30 minus 1 is 29. So option A is satisfying the equation that we need or the rule. Then question number 2. They want us to find the LCM. LCM stands for the lowest common multiple. So we have a number of ways of getting the lowest common multiple of any given numbers. We're going to look at the first option where you have to write down the multiples. Remember, multiples are basically products of a number with the natural numbers. So like 60 times 1 is going to be 60. 60 times 2 is going to be 120. Times 3 is 180. Times 4 is 240. Times 5, we get a 300. And then we have 360 and so on and so forth. Then we come down and look for the multiples of 45. So 45 times 1 is 45, times 2 is 90, times 3 is 135, and then times 4 gonna give us 180, and then we shall have 225, and so on. Okay. Now, when we look at the two options, we need to highlight what is common. So I'm already seeing 180 and 180 as the smallest number that is common. So which means my LCM becomes 180. Alternatively, we can use the ladder method where we have 60 and 45. And with this ladder method, we need to use prime numbers that can divide either one or both of the numbers. So the first prime number I can use is a 2. 2 can divide 60, but it cannot divide 45. So by 2, I'll have a 30. Since it cannot divide, I'll keep the 45. Let me use 2 again. 2 can divide 30 to give me 15. My 45 is maintained. Then 2 cannot divide any of the numbers. I can use 3 as my next prime number. 15 divided by 3 is a 5. 45 divided by 3 is 15. Then I can use 3 again. 3 cannot go into 5, so I'll maintain the 5, but 3 goes into 15. Those are 5 times. And then I use 5, everything reduces to just a 1. Then I'll get these numbers that I was using to divide, and then I multiply them. So my LCM is going to be 2 times 2 times 3 times 3 times 5. So this is going to be 4 times 9 times 5, which is 180 still. Okay, this is option 2. Then option number 3 is where we use the prime vectors. Okay, you break down this, but individually. So an example, when you look at 60, 60 can be written as 2 squared. Why am I putting a 3? It's squared. Okay, 2 squared times 3 times 5. Okay, the numbers that divided 60 is 2, 2, 3, and 5. 2, 2, 3, and 5. Perfect. And then when I look at 45, so 45, numbers that divided 45, we start from here. We have a 3 squared, and then a 5. Okay, now when I'm looking for the LCM, just multiply these numbers, but just once for those that are repeating. An example, there's a 2 here, there's no 2. So I'm going to use 2 squared. With the 3's, there's a 3 to the exponent of 1, there's a 3 to the exponent of 2. I'll use 3 with the 2. And then the 5's have the same exponents, so I just use one of them. So this is the same as this 2 squared, 3 squared, and then a 5, which gives us 180. So we have 3 options to choose from. The question is not dictating on which option to use. So whichever one you use, we shall be happy to give you all the marks. 2.1.2, Dabo wants to borrow 200 rands and then the bank asks for 7% interest per year. If he borrows money over 3 years, how much will he have to pay? All right, so with this, there are 2 options still. So you can say that our interest is given as P times the I times the N, where P is the principal amount, the initial amount that was borrowed. I will be the interest rate, and then N is the period of time. So if I get my 200 times the rate is 7%, which is given as 7 over 100, and then the N is the period, which is 3. If we simplify this, these 2 zeros can cancel those 2 zeros. I have 2 times 7 times 3, which gives me 42, which means that in total, Tabo must pay the 200 but also with the extra 42 rands, which becomes 242. Alternatively, we can use the simple interest formula, 1 plus IN. Okay, the letters still represent the same thing. So that's going to be 200 into 1 plus 7 over 100 times 3. So this will straight away give us the answer. And then that is question 2.1.2. And then 2.1.3. They're telling us that if 1 kilogram of milk, okay, so we're comparing milk and fat. So 1 kilogram of milk is giving us 2.8 kilograms of fat. How about 3.77 kilograms of milk? How much fat can we get from that? So we know that in this case, the amount of fat is going to increase, because as you increase the amount of milk, even the fat must increase. So it's going to be 3.77 over 1 times 2.8. And that will give us 10.53 kilograms or 52 kilograms. Okay, so that is question 2.1.3. 2.2, which talks about the integers. So from 2.1, actually the whole of 2.1, that is just algebra. Okay, and that algebra is specifically referring to what we call the whole numbers as a topic. Then 2.2 is also algebra, but with a specification of what we call the integers. Okay, so with integers, we have to pay attention to the signs. How do the signs relate with each other? Okay, and how do they affect each other? So in this case, a negative outside a bracket is going to be just negative 18. This positive next to a negative must give us a negative 9. We know that negative 18 minus 9 must give us negative 27 for 1 mark. Then 2.2.2, since we have more than one sign, we have a multiplication, we have also an addition, we can apply what we call our BODMAS. Okay, so with the BODMAS, it's just a rule that we use to show the priority of the different symbols or operations. So division comes first, then multiplication, addition, and subtraction. In this case, we have just a single bracket, which is not a big deal, okay? So negative 4 times negative 2 will give us a positive 8, because we know that same signs, okay, same signs must always be positive, and then different signs must always give us a negative answer, for as long as we are multiplying and for as long as we are dividing. That's when this rule applies. So with multiplication, same signs will give us a positive 8. And then plus and a negative, this is more like a multiplication. Positive and a negative will give us a negative 4. So 8 minus 4, and then we get the 4. Do not just punch this in the calculator, because you will get the correct answer, which is a 4, but you'll be losing out marks for the working. And then now 2.2.3, we have fractions, okay? They're telling us that 3 whole numbers, 2 over 6, plus 1 whole number, 1 over 4. What we can do, we can start by adding the whole numbers. That's option number 1. So we know that 3 plus 4, so 3 plus 1 is a 4. And then with the fractions, we have 2 over 6. If we reduce this by 2 is 1, by 2 is a 3. So you have 1 over 3 plus 1 over 4. You have to find your LCD or LCM. What I prefer doing is the cross multiplication, crisscross. Okay, so that's going to be 4 times 1 is a 4, 3 times 1 is a 3, over 3 times 4, which is a 12. So that's going to be 7 over 12. So my answer is going to be 4 whole numbers, 7 over 12. See, this is option 1. The other alternative is where you look or change this into improper fractions. So this would be 6 times 3 is 18, plus 2 becomes 20 over 6, plus 4 times 1 is 4 plus 1, that is 5 over 4. We can reduce this since we can divide it by 2. So by 2 we get a 10, by 2 we get a 3. So it's like 10 over 3 plus 5 over 4. We can do our crisscross again. So 10 times 4 is a 40. 3 times 5 is 15 over 12. So 40 and 15, that's going to be 55 over 12. And then the question is, how many 12s can we get in 55? So it's basically 4 12s, because 4 12s will give us 48. And then 55 minus 48, we get 7 as a remainder. So 4 whole numbers, remainder 7. So 4, 7 over 12. That is option number 2. Then 2.2.4. We cannot divide fractions, okay? So the trick is that we always change this to multiplication, and then we switch the position of the fraction that immediately comes after the division sign. So that's going to be 1 over 6 times 4 over 3. Then we can apply the multiplication whereby the rows multiply with the rows, and then the numerator separately, denominator separate. So 1 times 4 is going to be 4. Then 6 times 3 is going to be 18. And then we simplify this because we can see that the two numbers can be divided. So 4 divided by 2 is a 2. 18 divided by 2 gives us a 9. So that is 2.2.4. All right. Question number 3, which is the algebraic expressions. Okay. So these are algebraic expressions. That's yet another topic still under algebra. So they're telling us that if you're given this kind of expression, 3x minus 4x squared plus 2x cubed minus 1, how many terms are there? So we can differentiate or distinguish terms by looking at the plus and the minus signs, because those two signs or operations are the ones that separate the terms from each other. So we have a minus here. There's a plus there, and then we have the minus. So we have 3 operations there. So we only have to say plus 1, and that gives us 4 terms. Alternatively, this is a term 1, this is a term 2, this is a term 3, and then that is also a term 4. So that is how we count those terms. All right. Then 3.1.2, they want us to get the coefficient of x squared. Now, coefficient is basically a number that comes before the letter. So a number together with a sign that comes before the letter. So in this case, our interest is x squared. So we go to the expression, we look for x squared. So the number and the sign in front of x squared is this 4 together with the sign. So it is negative 4. Then 3.1.3, they want us to write down the constant term. So the word constant simply means a term with no variable. So a variable is a letter. So any number without a letter becomes a constant. So in this case, we're seeing that this one doesn't have any letter, doesn't have any x. So take the number together with its sign. So our constant term becomes negative 1. Then 3.1.4, write down the highest degree. So a degree represents the exponent. Okay, so the highest exponent. Remember, if that's a base, the number that is raised to another one becomes the exponent. So in this case, we have 3 as the biggest exponent. So the degree of the expression is 3. Then 3.2, we're given these expressions that must be simplified. So the instructions are telling us simplify. So when you're simplifying, you're trying to break down. And we can only do that when we collect like terms together and apply the operations. So in this case, I have my 5x together with this 2x, but the sign in front is a negative, so minus 2x. Then I have my constant term, which is 8, and then another one, which is negative 1. So a number and the sign before it, a number and the sign before it. Then 5 minus 2 will give us 3. So this is just for the group of the x's. Let's subtract them because these are like terms. Then the constants 8 minus 1 will give us a 7. But that 7 is positive because it's not a negative 7. So this becomes the answer. So we cannot add these two because they are not like terms. So leave the answer like this, and then you get your full marks. 3.2.2, we are multiplying. Okay, whenever we have a scenario like this, under multiplication or division, work with the numbers separately and then the variables separately. So we know that 2 times 3 is going to give us a 6. But now this is x squared, this is x cubed. So if we are multiplying numbers with the same bases, in this case, the base of x and the base of x, we must add up the exponents from our laws of exponents. So 6x, 3 plus 2 is a 5. So this becomes our answer. Do not make the mistake of raising 6 to the 5 again and you end up with a big number. That would be incorrect. Then 3.2.3. They want us to divide expressions. So the rule for this is that you must split up, okay? Everything that is on top must share a bit of the denominator. So it's going to be like 16a divided by 4 minus 4a cubed divided by 4, then plus 8 divided by 4. Then we go on, break down each term separately. So 16 divided by 4, how many 4 do you have in 16? It's just 4. Okay, together with the letter. Then 4 divided by 4 is just a 1. So in algebra, we normally don't write those ones. We ignore them. We call them ghost ones or invisible ones. And then plus, we have 8 divided by 4. That gives us a 2. Once again, there's nothing we can do to these terms because they are not like terms. Okay. Remember, like terms are basically terms that have the same letters and the same exponents. Okay, so the exponents are different. This one doesn't even have a letter. So these are not like terms. 3.3, they want us to solve. So when you're solving, you must find the unknown. Okay, so in this case, what is the value of x? We must show our steps. So the trick is simple. We need to leave the letters on one side and then move all the numbers to the other side of the equal signs. Okay, so in this case, x and 2x are on one side already. Good. Then what is stopping us is this 5 must be moved to that other side. Remember, it's a negative 5. When it crosses the equal signs, it should become a positive. So negative 13 plus 5. So x and 2x is going to be 3x. Negative 13 plus 5 must give us negative 8. And then for us to get x alone, because that's what the question was asking for, get rid of anything that is around x. So I'll divide by 3. I'll divide by 3. So my x becomes negative 8 over 3. Alternatively, you can write it as negative 2,667. All right, so that is 3.3. But we would prefer if you left it as this type of fraction. All right, question number 4. They're asking us that we must study the pattern and answer the questions that follow. Okay, so it seems that the first number is 18. What are they doing with the 18 to get 24? What are they doing with the 24 to get 30? And so on. So which means they are adding 6. Okay, they are adding 6. So when you're dealing with number patterns, the number that you continuously add or subtract to create a pattern is what we call the common difference. Okay, so common difference, another term or another word that we normally use is what we call the constant difference. Okay, so 4.1.1, they're asking us for the constant difference. It's just a 6, 1 mark. Then write down the next 3 terms. So from 42, we must also add a 6, which means we're going to have a 48. Plus a 6, we're going to have a 54. And then plus 6, we end up with a 60. Those are the next 3 terms. Then in 4.1.3, they want us to write in your own words the rule that describes this particular pattern. So you can say that starting from 18 or starting with 18, we must add 6 to the previous term. Okay, to obtain the next term. So that is the description that we would want in this case, for as long as they talk about the words then just use the constant difference and what is happening. Okay. Some learners might just say we must add 6 to the previous for us to obtain the next term. That is perfect. 4.2. We have this geometric pattern. Okay, a dot, 3 dots. So it's 1 dot, 3 dots. These are 6 dots. And then these are 10 dots. Okay. Look at the pattern above and then draw pattern number 5. So when I look at the way the combination is growing, it's like +2, +3, +4, which means the next one must be +5. But the arrangement itself also matters. 1 dot first, 2 dots on the bottom, 3 dots in the bottom, 4 dots, and then they keep on reducing to the top, which means we're going to have 5 dots, okay, 2, this is 3, 4, and then 5. Then we're going to go for 4 dots, and then we're going to have the 3 dots, we're going to have the 2 dots, and then we're going to have 1 dot. So for as long as we count the dots and they're 15 and they're forming some sort of a triangle, we are good to go. So is this a numeric or a geometric? So since these dots are not representing numbers, we can call them geometric. Okay, remember numeric is numbers or a number pattern. That is numeric. Geometric, you're using shapes to represent that at grade 8 level. 4.3. 4.3. This falls under the functions. 4.3 is functions. 4.2 was number patterns. Okay, so we must use the rule. So this one is going to be our input, and then this is our output. Okay, so we know that 13 minus 6 gives us 7. So what is 12 minus 6? Okay, that's going to give us a 6. And then 11 minus 6, that's going to give us a 5. Then for us to get the input from the output, we must apply the inverse operation. So it's going to be 2. Instead of subtracting, we must add the 6. This gives us 8. And then we have the input, so it's going to be -4 minus 6 gives us -10, which is our answer there. Then for us to get the input for -11, we said inverse operation. So -11 plus 6, we get a -5. So just like that, you get your 5 marks. Question number 5. I just said rhino population. So this is the vertical axis, okay, vertical axis, and then this represents the horizontal axis. And then the numbers were plotted or they were drawn. All right. So what does the graph represent? So we have a title here or a heading. So we're saying the graph represents what we call the rhino population. Then identify the dependent and the independent. So independent variables are those variables that are not affected by other variables. And in most cases, we find these variables by the horizontal. Okay, so that is the independent variable. Then the dependent will be found on the vertical axis because this one depends on what is down here. Okay, so just to answer the question, so dependent variable is going to be the population. Okay, population becomes our dependent variable. And then the independent variable. Independent, remember we said there. So there becomes the independent variable. So that's how we are meant to answer that particular question. Then is this graph continuous or discrete? So the difference between the two is that a continuous graph is one where the points of the graph are connected to form some sort of a line. It can be a broken line, a straight line graph, or even a curve. So that will be continuous. Discrete is where the points were just drawn, points were just scattered and left, but we can easily see the trend. Okay, so in this case, the graph is continuous. Okay. Then 5.1.4, what was the rhino population in 1997? So someone would say, but we don't have 1997 here. Remember, this is a graph. We must use our knowledge of estimation, okay? And since it is a grid, there should be lines that were drawn. So this 1, 2, 3, 4, and then 5. So we have intervals of 5 years. Okay. So if this is 1995, which means the next one is 96, 97. Okay. Question is asking about 97. So we shall follow this vertical line of 97 up until it meets the graph, and it's meeting it at that point. Then we move to the horizontal and see what number is there. So we're seeing 25. So which means in 1997, we had 25 rhinos. And then what is the maximum population? So maximum population from a graph is the highest point of the graph and not the last number. Okay, so it cannot be 35 because the graph is not passing through 35, but the graph is reaching the highest at 30. So which means that our highest or maximum is 30. And then the minimum is the lowest that the graph reaches. Okay, so the graph starts from 0, but the lowest that the graph reaches is 10. So which means our minimum population is going to be just 10 rhinos. All right. Then 5.1.7, what happened to the population between 2000 and 2005? So 2000 is here. 2005 is here. We can see that the graph is dropping downwards. And we know that this kind of trend is what we call a decrease, okay? So we're going to say that the population decreased. That is one. So population decreased, and then they want us to give a reason. So possible reasons why game park animals like the rhinos decrease is because of poaching. Okay. Probably there was increased poaching. There was increased poaching of the rhinos. Then 5.2, they want us to complete this table of ordered pairs using this equation. So what we can see is that we are going to use our substitution, which means that for the first letter A, y is going to be 2 times -1 minus 2. So that's going to be -2 minus 2, which gives us -4. For the B, where there is x, we put a 0. So 2 times 0 is 0, 0 minus 2 gives us -2. For the C, I'm going to replace y with a 2 because we're looking for the input. Let's move this to that side. It's going to be 2 plus 2, which is a 4, is equal to x. Then divide both sides by 2, which means x is just a 2. So that is how 5.2.1 would be answered. Then they want us to use these points to plot our graph. So if we have -2, -6, then we have -1 and we said -4. We have 0 and -2, 1 and a 0. I hope I'm right. Yes, and then 2 and 2. So we need to plot this. So the numbers on top are representing the x values, and then the numbers down are representing the y values. So these are the ordered pairs. So when you're plotting a graph, you start with the x values. So let's locate this point. So -2 along the x is here. Okay. Then we need to move along that line of the x so that we find the y that is -6. So this line, -6, is down here. Then we move on to -1. -1 for x goes with -4 for y. So -1 for x, -4, which is that. And then 0 is going to go with -2, which is this point here. And then we have 1 that's going with 0, which is that point. And then lastly, 2 is going with 2. So 2 for x and 2 for y, where their lines meet. Okay, remember 2 for y, 2 for x, they meet. 0 and then 1, 0 and then -2, and so on and so forth. Okay, so we can see that our points are forming some sort of a line. So get your ruler and then connect these points so that you form a straight line. Okay, so that is the graph that they wanted, and that brings us to the end of this paper. Thank you very much, and then let's meet as we discuss paper 2. Bye-bye.